Yeah.
All right. So today's topic is going to be complex numbers. Okay. So I'm going to take it right from the basics first.
Okay.
All right. So you have studied about different kinds of numbers in math, right? For example,
Yes.
you know what are integers, you know what are rational numbers, irrational numbers, all of that, right? But this
Yes.
complex numbers, I think this is the first time, like in 11th grade, you're hearing it.
Yeah.
Am I right? Yeah.
Yeah.
So, in complex numbers, what are complex numbers? Where is it coming from actually? Because in math, we have actually just two kinds of numbers. Okay. We have two kinds. The one is the real one that you have studied, all of them, and the other one is the imaginary numbers. Okay. Now, while I'm writing the things on the board, you can just pay attention. Once
Mm.
I am done writing, so that you're just focused on one place. That's my motive of just saying that. That
Okay.
you pay attention to this. If you want to note something, you can ask me to hold on. You can note. I'll wait. Okay.
Sure.
But when I'm writing, you please listen and understand.
Sure.
So the real numbers are the ones that you have done so far. Like we have covered what are natural numbers in school. You have done that, right? In small classes. Then you know what are whole numbers. You know what are what integers.
Yes.
You know what are rational numbers. You
Yes.
know what are irrational numbers, right? All these numbers you have learned, and all these are actually.
Camera is not presenting the share screen.
Sorry, I couldn't hear you. Your voice is breaking.
The screen is not seeing the sharing what you're sharing.
I still cannot understand. Your voice is breaking actually. Can you say
Oh,
something now?
1 second. Can you hear me now?
Yes, I can hear you fine. It's okay. You can keep your camera off like for 2 minutes, okay? And then you can turn it back on, right? But please listen to what I'm saying. The screen is not, I think it's there, but maybe because of the network issue, you're not able to see it, but it is shared. Can you see it now? Hello? Kashvi, please fix your network.
Hello.
Yes. Can you hear me now?
No, I can't hear you. I just can hear like little bit.
Can you see the screen?
Mm-hmm. Just a minute.
Hello?
Yeah, I can see the screen now.
Okay. Yeah. Okay. So I was saying, like in math, there are two types of numbers, real numbers and imaginary numbers. Okay.
Yes.
You have learned about the real numbers till 10th. You have learned what are rational numbers, natural numbers, whole, integer, irrational. Other kinds are also there. Okay,
Yes.
but right now we are going to learn about the imaginary numbers. Okay, and the complex numbers, they come under the imaginary numbers, right?
Okay.
So this is
Yes.
what the main thing is about. We are going to learn about the imaginary numbers, right?
Okay.
Now, what do we mean by the imaginary numbers? Now, you might have done like, what is the square root of 4? What is the square root of 4?
Sorry.
What is the square root of 4?
4.
Hello.
Hello.
Yes, yes. Please tell me, what is the square root of 4?
Sorry, I don't know.
Uh, okay, the square root of 4 is 2, no?
Yeah.
What is the square root of 9? Okay, tell me, what is the square of 9? What is 3 times 3? That is 9,
Fine.
right? So when
Yeah.
I'm saying anything as a square root, that means you have to do the opposite. So
Oh,
what squared makes square root of 9? So what squared makes
3.
9? Which is
3.
3. Okay, so that
Oh,
means square root of 3 is, sorry, square root of 9 is 3.
3.
Similarly, what will be the square root of 16? 4,
3.
because
Oh,
4
4.
times 4 is 16,
Yes.
right? So that's what we mean by a square root.
Okay.
Okay, now this is what we have. Now suppose I tell you, what is the square root of 1?
1.
Exactly. But what would be the square root of minus 1? Now that
Minus
you don't
1.
know. No, no, no. It's not minus 1. Okay. Square
Okay.
root of minus 1 is not there. That is
Yes.
what you call is a complex number. Now this has become a complex number because there is no square root of a negative term.
Mm-hmm.
Okay. For example, if you are doing square root of minus 2 also, it is also nothing. It's square root minus 2. So this has become a complex number now.
Okay.
This is an imaginary number. Okay.
Mm-hmm.
So whenever we do the complex numbers, we write it by the term iota. What do we call it? Iota. IOTA. And this is how
Iota.
you denote it.
Okay.
Okay. And this is equal to square root of minus 1.
Okay.
Okay. So if I'm saying what is iota, iota means the square root of minus 1.
1.
Okay. Now suppose I have a number like square root 4. Okay.
Mm-hmm.
And I'm saying you're doing the square of a square root. Then what will
Mm-hmm.
it be? You know the square and the square root, they cancel out each other. And the
Mm.
answer is 4.
Yes.
Okay. Tell me if you have square root of something, let's say square root of 4. So if you
Mm-hmm.
want to write it as a power, right? So what
Mm-hmm.
square root is what power?
2.
1 by 2. 2 is
Okay.
squared, no? If I
Yeah.
write 4 squared,
Mm-hmm.
that's 16. But if I'm
Yeah.
writing square root, that means 4, 1 by 2.
Okay.
Okay. So
Mm-hmm.
whenever we do the square and the square root together, the square and the square root, they actually cancel out,
Okay.
right? So we have to always remember that iota is equal to square root of minus 1.
1. Okay.
Simple.
Yes.
Remember this thing. Now, when we talk about the complex numbers are always written complex numbers. So the complex numbers, they're always written in the form of a plus iota b, okay, where a is your actual number, like the real part of the number, okay, and
Mm-hmm.
b is your imaginary part of the number. I'll explain this with the help of an example.
Okay.
So this is the imaginary part, or you can say the imaginary part of the number. For
Mm.
example, if I'm writing something as 3 plus 4 iota, okay, so what is a? A is the real part. So A is 3. What is B? B is 4. Because
4.
this is with the iota, so it becomes the imaginary part,
Mm-hmm.
right?
Yes.
Is this understood? Okay, let's say if I'm writing something as 2 minus 7 iota. So what is
Mm-hmm.
the real part
2.
and what is the imaginary part?
7.
Minus 7. Keep the
Okay.
signs also. Okay, whatever is
Okay.
the sign to is whatever sign is there to the left of a number, that's the sign
Mhm.
of that number. Okay, so here you
Okay.
have like at the left of 7 you have minus, so minus
Okay.
7 is the number.
Okay.
Okay, so a is 2 and b is equal to minus 7.
Okay.
Right? So always the complex numbers will be written in this form: a plus iota b, where a is the real part, b is the imaginary part.
Hmm.
Right? And what is iota again?
Iota is the imaginary part or
No,
the
no. I told you the value of iota. No, iota has a value
minus
to
1.
it.
Square root of minus 1.
Very good. It's square root of minus 1.
1.
Okay. Can you please try turning on the camera now? Maybe the network is fine.
No, like if I on the camera, the voice is lagging and even the screen is not appearing for me.
All right. So now you can write this down. What is a complex number? It's written in this form.
A plus
Okay.
IV form.
Yeah. You can write it down like in your notebook
Okay.
so that when you revise, you know what it is.
Okay. Okay. Done.
Okay. Uh, Next part. Now we are talking about the equality of complex numbers. Equality of complex numbers. You know what are complex numbers, no? Tell me again, what
Yes.
form are they written in?
A plus IB form.
Iota. It's not I, it's
Iota.
iota. Okay. So a plus iota b is the form. So if you're doing equality of something, let's say I have one complex number, which is z1 is equal to a1 plus iota b1. Okay.
Okay.
And there is another complex number, which is z2, which is written as a2 plus iota b2. Okay.
Mm-hmm.
Now, these two numbers will be equal to each other only if A1 is exactly equal to A2 and B1 is exactly equal to B2.
Beta.
Okay. Example, if I say Z1 is equal to 3 plus 4 iota. Okay. And Z2 is also equal to 3 plus 4 iota. Even the signs should be exactly same. Okay. Then
Okay.
only I can say that Z1 is equal to Z2.
Mm-hmm.
Right?
Oh. Yes.
Okay, let's say I have Z1 is equal to 7 plus 8 iota, and I have Z2 which is equal to 7 minus 8 iota. So can I say that Z1 is equal to Z2?
No, because the signs are different.
Exactly. What signs are different?
Minus and plus.
Right. Here B is 8, whereas B1 is 8 and B2 is minus 8.
Minus 8.
Exactly. So equality of complex number only works when A1 is exactly equal to A2 and B1 is equal to B2,
Beta.
considering their signs.
Okay.
Okay, you can write this. Or maybe
Okay.
you can do one thing, you can take a screenshot and save them at one folder so that.
Sure. Yes, done.
Okay. Now we're going to talk about the addition of complex numbers. Okay, how do you add the complex numbers?
Mm-hmm.
It is very easy. I'm going to tell you that with the help of example. Okay,
Okay.
so we know in a complex number there is real part and there's imaginary part. Okay,
Yes.
so when you're adding two complex numbers, you're going to add the real parts separately and you're going to add the imaginary parts separately.
Okay.
Right? For example, if I have z1 is equal to 3 plus 5 iota and we have z2 is equal to 4 plus 7 iota. Okay, and I tell you, please tell me what is z1 plus z2. So what are you going to do? 3 plus 5 iota
3
plus,
plus 5 iota plus 4 plus 7 iota.
exactly. So add the real parts. What are the real parts here?
3 plus 4.
Exactly, which is 7,
Yes.
right? And what is the
Yes.
imaginary part? Now you keep the iota side. You just add the 5 and 7. Okay? So you will do 5 plus 7 and iota is outside. It's still an
Okay.
imaginary term, but you will add
Okay.
this. So it's going to be
7
7,
plus 12
12 iota. That's
iota.
your answer for the addition. Simple?
Okay. Yes.
Okay. Now let's say I'm doing the subtraction of them. Okay.
Mm-hmm.
Please tell me what will be Z1 minus Z2. Now, one more important thing. When you're
Mm-hmm.
writing Z1, you're going to write 3 plus 5 iota. But when you're going to write Z2 minus, you'll put that inside the bracket. Why? Because there's a minus outside.
Okay.
Okay, it's common for everyone. Even if you're doing algebra, you're doing any number. If there are like set of numbers, you always keep them inside the bracket. If there's a minus outside, because otherwise you mess up with the signs later.
Yes.
Okay, so 3 plus 5 iota minus in the bracket 4 plus 7 iota. Now what's my step? The next step.
The real part, that is 3 plus
First
4.
you'll have to open the bracket, no?
4 plus
Right?
7.
No, no. You open the bracket. 3 plus 5 iota. Now there's minus.
Yeah.
Minus 4. So it's going to become
Okay.
minus 4. And plus times minus is again minus. Minus
Yeah.
7 iota. See,
Okay.
the minus sign changed everything inside the bracket.
Okay.
Okay? You understood
Yeah.
why the 4 and 7 iota became minus?
Yeah, I got it.
Because there was a minus outside, so you
Yeah.
multiplied the minus with them. Okay.
Yeah.
Now you come to the solve. Now you come to solving the real part and the imaginary part.
Yeah. So since there's a change of symbol, it will it become 3 minus 4?
Exactly. And what is 3 minus 4?
Sorry, minus 1.
Exactly. 3 minus 4 is minus 1.
1.
Okay. And what about this part? I'll do 5 minus 7 iota will be outside.
Minus 2.
Exactly. So minus 2 iota. Now this is your answer.
Oh,
Understood?
yes.
Okay. If I give you a question, will you do it from the beginning for the subtraction part?
Yeah, I'll do it.
All right. So let's say Z1 is equal to 6 plus 3 iota or iota 3. You can write it anyway. Iota 3 or 3 iota. Same thing.
Okay.
And Z2 is equal to 5 minus 2 iota. Okay. Please tell me what will be Z1 minus Z2. Follow it step by step. Okay.
Okay.
And please turn on the camera. Maybe it will work now. I'll be checking your notebook. So write each and every step clearly.
Okay. Can you see me?
Yes, I can see.
Okay. Yeah, I got the answer.
Please tell me
1 minus 1 iota.
this. Okay, let me do it. Can you show it on the screen, please? Like, keep your notebook in front of the screen.
Yes. I'll reverse the camera. Is that okay?
Yeah, fine.
It's not. Let me see.
Uh, can you bring it closer? Okay, I think it would be better if we reverse the camera.
Yeah.
Yeah, please keep it there. Hmm. All right. Now, there's one mistake.
Okay.
Tell me what is negative times positive?
Negative.
Right. What is positive times negative?
Negative.
What is negative times negative?
Positive.
Exactly. So that means you're going to do 6 plus 3 iota minus 5 minus 2 iota. Correct?
It,
Now, once you
yeah.
open up the bracket, you got your mistake?
Yeah, yeah. It changes to the plus sign.
Exactly. So you'll open up the bracket 6 plus 3 iota. Now open up the bracket. The 5 will become a minus 5 and the minus 2 iota will become a
Plus 2 iota.
exactly. So minus 5 plus 2 iota, right?
Okay. Yeah.
Yeah. So now you solve the real part and the imaginary part. 6 minus 5 will be 1 and 3
Yes.
plus 2 will be 5 iota.
Yeah.
All right. So keep the track of the signs. That's why I said the signs are important, right?
Okay.
Whenever there is a negative outside, what happens to all the terms inside? They change their sign when they come outside the bracket.
Yeah.
Okay. So any doubts
No,
for
I
this one?
understood.
For
No, I
addition
understood.
and subtraction, I think, hope that's clear.
Yeah, it's clear.
Okay, Kashvi. Now let's move to the other topic, okay? And
Okay.
we'll do the basics and then we'll do the questions again.
Okay.
What did I tell you? What is iota?
Minus 1. Root minus 1.
Root minus 1. Now, if I do iota squared, then what does that mean? I'm doing root minus 1
Minus 1.
whole square.
Yeah.
And what will happen now? What is square of root minus 1?
I'm getting confused with that.
Okay. What is root? Root is 1 by 2, I told you. If you
Yeah.
write root in terms of powers, then it is 1 by 2.
Hmm.
If you're writing 2 square root, it's same as 2 1 by 2.
Hmm.
Okay, square root means 1 by 2. If you want to write it as a power, it means 1 by 2.
Okay.
Right?
Yeah.
So if you're writing, if I'm doing what? I'm doing minus square root 1, which means minus square root 1, 1 by 2. Instead of a
Hmm.
square root, I've written 1 by 2.
Hmm.
Okay? And I am doing minus square root 1 whole square. So whole square. What does that mean? I'm going to multiply the powers.
Yeah.
I'm telling you a concept behind it. I would simply tell you that the square root and the square root cancel each other. But why are they canceling each other? This is the understanding part. I'll take
Okay.
it again. I'll take it again. Okay. So minus 1 square root. That means minus 1 to the power 1 by 2. Because square root means 1 by 2.
Yeah.
Right?
Yeah.
Okay. Now if I'm doing square root minus 1 by 2 to the whole square. So what will I do? Minus 1 by 2 minus
Hmm.
1 to the power 1 by 2 whole square.
Yeah.
That's right?
Yeah.
Understood? Okay. Now, if you remember, one of the exponent laws it was that whenever there are two powers, then they get multiplied.
Yeah.
Okay. For example, if it is 2 to the power 3 and then there is one more power 2 outside. So if you open the
3
bracket,
to
it's going to be 3 times 2, which will be 6. So
yes.
it becomes 2 to the power 6. So you actually multiply the powers.
Okay.
Okay. This is the law of exponents, one of the laws of exponents.
Okay.
Whenever you're multiplying the powers, whenever there are two powers, one outside the other, then you always multiply those powers.
Okay.
Okay. So here also, I have 1 by 2 as one power and 2 is the other power. So what will I do with the powers?
Multiply.
Exactly. And what is 1 by 2 times 2? 2 and 2 cancels out. 1,
Yeah. 1.
right?
Yeah.
Which actually means that it will be minus 1 to the power 1 because 1 by 2 and 2 cancelled out each other,
Hmm.
right? Which is
Hmm.
minus 1 because
1.
anything to the power 1 is
Can't hear you.
yes. Can you hear me now? I think
Yeah.
there's okay. So minus 1 to the power 1 will be minus 1,
Yes.
correct? So this
Yes.
concept is this understood. The main
Yes.
thing behind it is that
Mm.
the square root and the square, they always cancel each other. Okay. So if you have taken the square root and the square of the same number, they will cancel each other and your answer will be just the number which was inside. For example, 2 square root whole square. So the square and square root will cancel. Your answer is 2.
Two.
Okay. If you have 3 square root whole square, then the square and square root cancels out each other. The answer is 3.
Three.
Okay. This I explained this part
Mm-hmm.
just to tell you why are they canceling out.
Okay.
Okay, because they cancel out, they make 1, and anything to the power where that is that.
Okay.
Was this clear?
Yes.
Okay. So tell me now, what will this become? Yeah.
One.
Iota squared is equal to square root of minus 1 whole square. So this is equal to,
One.
is there only 1 inside? Whole thing,
One.
minus 1,
Yeah. Minus one.
right? Because the square and square root cancels each other. That
Yeah.
means iota squared is going to be 1. Minus 1, sorry.
Okay.
What is iota? I'm going to write them side by side also. Okay, iota was square root of minus 1. When I did
Yeah.
iota squared, I got minus 1.
Okay.
Okay, but now if I do iota cubed, then what can
Mm,
be iota cubed? Iota cube means it can be written as iota squared times iota,
yeah.
because what can 3 be written as? 3 can be written as 2 plus 1 or 1 plus 2, anything.
Yeah.
So if you remember one more laws of exponent, it was iota squared. Like whenever two things are getting added, you can write them separately with a multiplication.
Yeah.
You remember that exponent law where it says that whenever you have same basis and then you add the powers
Yeah.
and they get
The
multiplied,
yes.
right? For example, if it is a to the power 2 times a to the power 7, I have same
Two
basis.
sevens.
No, add the powers. When you have
Okay.
same bases getting multiplied, you will add the powers. So that's
Okay.
a to the power 9.
Yeah. Okay. Got it.
Okay. So I'm just going to split this. It was iota to the power 2 plus 1, which can be written as iota squared times iota. Why? I actually did the opposite of it. I
Okay.
wrote 9 as 2 plus 7, right?
Mm,
And then
mm,
2 plus 7 I wrote as a to the power 2 times a to the power 7.
yes.
Right? So iota cubed is actually, what is iota squared? We got it as minus 1.
Minus one.
And what was iota? It was
My
square root
square
of minus 1.
minus one.
Right? So I can
Yeah.
just write that iota cube is actually minus iota, because this is minus and this is iota. So iota
Yes.
cube is minus iota.
I,
Simple.
yes.
Now I'll come to iota to the power 4 and then I'll tell you a general formula. Okay. Now
Okay.
what is iota 4? Iota 4 can be written as iota 2 plus 2.
Yes.
I could write it as 3 plus 1 also or 1 plus 3 also, but that would be little complicated. So I took it as 2 plus 2. Okay. Which means it can be written as iota squared times iota squared.
Yes.
Correct. Now what was iota squared? Minus 1.
Minus one.
And the other one is also iota squared. So minus 1 times
Minus one.
minus 1. Minus times minus is plus. 1 times 1 is
Plus
1. So that is
one.
equal to 1.
One.
Iota 4 is equal to 1.
One.
Simple.
Yes.
Any doubts?
Nothing.
Right? So you have to actually remember these four values.
Okay. I'll make a note of it. Just a
Yes.
minute.
And also try to remember it right now.
Okay. Yeah. Done.
Huh?
Yes.
Okay. Learn it. Remember the values, please.
Yeah.